Hello everyone, this is Win Harden. You're here on the set of Manufacturing Matters in Boston, where we're at the Vision Show, which is co-located with the Autonomous Mobile Robotics and Logistics Show. And today I'm lucky enough to be with Marc Larive, who is Strategic Marketing Manager at Xenics. So Marc, if you could kick us off by telling us a little bit about Xenics, what makes you special?
Okay, hello. So I'm Marc Larive, Strategic Marketing Manager at Xenics. And Xenics is a Belgian company, and we are specialists in designing, manufacturing, and selling infrared cameras, both in shortwave and in longwave. So shortwave, typically it's 900 nanometers to 1,700 nanometers, so just next to visible.
Right.
And longwave is 714 micron, so it's really for the temperature visualization. Okay. So what we do at Xenics, it's really the design of the sensor, the core, and the camera. That means we design our own sensor, including the readout circuit. That means the core of the camera.
Right.
So that's basically what gives the final performance and capabilities and functions of the camera or the sensor. And we can provide at each level sensor, core, that means sensor plus its electronic and camera. So that's for the shortwave.
Okay.
And for the long wave, we design the cameras. We have several kind of cameras, but mainly industrial camera. Very small one that can be embedded in big systems or even small systems, and really plug and play industrial camera. You just plug the camera on your system or even on your laptop, and you get the picture.
Right. Is that embedded space becoming more of an important area for Xenics?
Yeah, so the embedded space is more and more important because especially in machine vision, people are using more and more the infrared to check the quality, the process, and all this. And for this, the camera is usually not used alone, but is part of a bigger system.
Right.
So that's why we deliver cameras that are plug and play, but also we deliver we can offer the SDK so that it's embedded in bigger system and can communicate easily with the different parts of the customers.
Do standards play an important part of that? I mean, I'm used to, from the visible perspective, thinking GigE, thinking USB 3 vision, camera link high speed. How about when it comes to infrared?
So it is, indeed, because as I said, infrared, each time they have to use it in a process monitoring or inspection system, they use it, the customer use it in a bigger system, and it has to be standardized to easily communicate with the global system. So typically, camera link, GigE, or coax or whatever, these are the standard, and especially this GigE and camera link, these are standards that are very common in machine vision.
Right.
And yeah, we provide the SDK that are compliant. All our cameras are compliant with the standards, so that it's easy for the customer to integrate it.
That's wonderful. Interoperability cannot be overstated as an important aspect of cameras and every one of the machine vision components we're looking at. So I think that's really useful to have an SDK that adapts to all these different standards. That's beautiful.
Yeah, each time we deliver a camera, we design a camera. In fact,
yes.
we take care that it's compliant with the standard, with the interface that we offer with the camera.
Right.
If it's a GigE, then it's compliant with the standard. So that's important for the customer.
So what are we showing here in Boston today?
So in Boston, we have 3 live demo on the booth with unique products. In fact, the first one is a line scan,
right?
Shortwave, with a line of 2048 pixels, running up to 260 kilohertz full line.
Fantastic.
So it's something which is, first of all, it's the fastest you can find on the market. And it's very useful each time you need to make a fast control or inspection. It's also very useful for all kind of OCT inspection, optical coherence tomography,
Right.
which is used for the surface inspection on the first layers of the surface inspection. And shortwave plays an important role there because you can see a bit better, strongly better in fact, through some specific material, typically silicon. So yeah, with shortwave you can see through silicon. So that's the demo we have on our booth. We have a wafer with a name on the other side.
Right.
You look on the top and you can read the name. So just to prove you that you can see through. So that's for the line scan. We have also a VGA camera in shortwave, which is
So
the
it's a 640
latest.
by 480?
It's VGA 640 512, 640 512.
Yes, sir.
So it's 20 micron pitch and very, very sensitive. And you have to understand that in shortwave, the small pitch is not always beautiful. You are coming from visible, and you know that in visible, people are looking for smaller and smaller pitch.
Right, right.
In shortwave, you need light,
Exactly.
you need flux. So the bigger the pixel, the more flux you have. So in fact, what is relevant is the capacity to get the light, so big pixel, and the noise, which is in front of it.
Right.
So it's a ratio in between. And this camera has one of the best ratio you can find. So you can detect very teeny thing, very small contrast. So typically, again, in silicon inspection, you can see very small difference, which are still defects.
Absolutely.
So, and people want to eliminate this. So
Right.
that's a good way. On the booth, we show it on kind of food demonstration, just to show that shortwave is very useful for all the food processing and food sorting. So we mix some real food with some stones,
Right.
and you can just at looking at the screen, you can see the difference between both. So this is really useful and used in food inspection. And then the third camera is a thermal camera, so long wave from 7 to 14 micron, 12 micron pitch, and SWIR, that means 1280 by 1024. So it's an industrial camera with performance that are very close to scientific camera. So it's very, very stable. It's good for thermography.
And that's uncooled, right?
It's uncooled for sure. It's uncooled. It's designed to be industrial,
Right.
so plug and play, and it's the largest definition that you can find on the market for such thermal industrial cameras. So with this, we have it on demonstration, and you see the sensitivity of the camera.
Which was amazing. Is that the one that we were doing?
Yeah,
with
that's the one. Oh, okay, it's
Right. So we're standing in
it's
front of
not
the camera in the demo and taking our hand and then touching it, and you could still see the handprint on the suit as you take your hand away. It's just
Yeah,
amazing.
but that's just to show sensitivity. This camera is very, very sensitive, and more than the sensitivity is also the resolution. You can see very small and teeny defects with that because of the resolution, or you can check a wider area
Right.
with same kind of optics. So
Because
it's
of the size
always,
of the sensor.
Yeah, because of the size of the sensor. It's 1280 1024, so
Right.
that's very useful for thermography and for industry application. Usually people, they try to get one camera to measure the most they can.
Right. Largest area.
The largest area.
Right. So I have to buy the
so
fewest cameras.
either they have to buy plenty of camera,
Right.
or they can do it just by one.
Fantastic.
So that's one of the advantage of the 1280 by 1024. You cover a much larger area.
Wonderful. So we talked about wafer inspection. I'm going to guess that there's also a play in printed circuit board electronic assembly. We talked about food inspection.
Yeah.
obviously there's security and there are other applications too
Yeah.
that leverage your technology.
Security is usually using also thermal cameras or shortwave.
Right.
With shortwave, you see through the haze and fog much better than the visible.
Right.
And the advantage that the picture you get is very easy to understand because it's like a black and white picture. And thermal, you see the temperature, so it's also very useful in surveillance and this kind of area.
Mm-hmm.
The image is a bit more difficult to understand, but people in this field, they know it quite well, because here you see the temperature. You see the difference, the contrast in temperature. So it's not something that you are used to in the real life. But for detection of intrusion or this kind of stuff, that's really useful.
Okay. Now, earlier we talked about the growing need of or use of your technology in embedded systems. I'm just curious, as we talked about earlier, the ability to see through fog, penetrate. Is there a play for Xenics in our technologies in autonomous vehicles? Are we seeing it more in consumer goods, or is the performance level such that it's not optimized for that type of application?
So the camera that we develop for the moment are industrial.
Right.
They are not optimized for vehicle inspection in shortwave. In longwave, we have developed cameras that are the smallest you can find on the market, really very, very teeny cameras.
Right.
The camera is just 6 grams.
That's a board level?
That's a board, yeah.
Yeah.
It's just, you see a chip,
Right.
but in fact, the board is doing all the job. It's the chip, and it's a camera. So it's very, very small. So this can be used in, let's say, large surveillance and can be easily integrated and mass production
aerial,
for this.
drone.
Yeah, for all this kind.
Okay.
All this kind of application. In shortwave, for the moment, the camera that we design are more for machine vision, but can be used also for this kind of application.
Okay.
Definitely.
We talked about food inspection. Is Xenics technology moving into agriculture?
That's also one of the applications that can use the shortwave, and our cameras or sensors. We have cameras and we have sensors used for grain inspection, food inspection, food grading. Not only inspection. Inspection is just detecting whether there is a foreign object or not.
Right.
Grading is whether the meat is just meat, or you have plenty of bones in it, or plenty of fat, and depending on the proportion, you do different things with it. So
that's how they grade the Wagyu steaks, basically.
I don't know whether they use it for this, but they could, yes, definitely.
I think they could send more samples.
Yeah,
to us.
they could make the proportion between the fat and the protein. So, yes, that's what one of the use. The other one, you're right, is in agriculture to look at the maturity of the product, whether there is enough moisture on the soil, whether there is a stress because it's too dry, especially this summer, at least in Europe.
Right.
So yes.
Same thing here in the States out west.
So,
one of the worst summers we're having for ranchers, I know, out that direction.
So yes, this kind of cameras can be used for that.
So what is the single biggest application that Xenics technology, just general purpose machine vision, or is there a particular vertical industry where it is gobbling up most of your components?
No. We are in, let's say the main segment is industrial. So either inspection or process monitoring to get a close feedback loop. And surveillance is also a growing market. But we serve all these segments. We are also serving medical applications, medical application and transport.
Gotcha.
Plus, for sure, we start from the scientific market. We're still in scientific market.
Wonderful.
And it's still a big piece, a big part of the market. But I think the most, or the one which is growing with a steeper slope is probably the machine vision and the process measuring.
Marc, thanks again for joining us today on Manufacturing Matters. If anyone in the audience has any more questions about their long wave and shortwave solutions, give us a shout while you're sharing and you're liking this video and hopefully sharing the reasons why manufacturing matters out there. And until that time, look forward to talking with you again soon, Marc.